Oh, but it's my thing. It's not alright, you're not getting all back. You took my pen and now it's lost everything. Alright, let's begin. I'm gonna do a fast. On your 11, quiet down. Shh. Quiet down. Alright, excellent. Exercise 4A. Now, let's look at what we did last session. I'm going to revise each one of these, and then I'm going to go back to A, what A does, because that's what you were doing last session. You kept asking me, what does 2, what does 3 do? I'm going to focus on that, just so you can see what it looks like. I made a better graph this time, so it should be less confusing when I use GeoGebra. But here we go. Let's revise. What does the C do?
Up, down, up, down.
Up, down. Fantastic. This tells you up, down. What does the X plus B do again?
That's right.
Left and right. How do you find? Wait,
Zero.
quiet down. How do you find left and right? Will, if I want to know if this means left or right, what do I do? What's the first technique? No, there was a technique. What was the technique, Najma? You let it equal 0. Okay, so whatever this is, okay, let it equal 0 and solve for x. So here we go. I'm going to say let x plus b equal to 0, solve for x. Now, if x is positive, then what does it do?
Right.
It goes to the right. So when you solve for it, if it is positive, it goes to the right. If it is negative, it goes to the left. Okay, so that's what we were doing last session. We were trying to whether move up, down, left or right. Yeah? Now what was the shape of this and what was the name? What was the shape? How does this shape look? Lauren, what does the shape look? Just draw it in the air for me. Fantastic. It's one side and the other side is on the bottom. Yeah? So this is what the shape looks like for a 1 on x function.
Wow. Can you have a circular graph?
Yeah, we'll get there, but not at this point. So this is what we learned last session. We learned you got y equals 1 on x. This is the shape. Now notice the way I'm drawing it is approaching these lines here. It's approaching the vertical axes and it's approaching the horizontal axes. What were the names for that? What were they called again, Trent?
Asymptotes.
Asymptotes. Good. Now your asymptotes. When I went around and I corrected your exercise book, when I gave you a question each, I corrected you on, you had to label the equation. It's not good enough just to write 0. You had to write the equation. So, the horizontal asymptote, which you defined with the dotted line, okay, with the dotted line you would say y is equal to 0, whereas your vertical asymptote, you would do a dotted line and you say x equals to 0. Okay, these are the properties that I want to see. Now when you move left or right, these asymptotes will follow. If you move right, the vertical asymptote will move across as well. If you move up, the horizontal asymptote will go up as well. You're going to use these asymptotes to sketch the graph. And that's what I'm going to try and teach you today, just to make sure you get that correct. Okay? Now, A, which I've just given you there, what does A do? Good. Now, unlike quadratics, quadratics had a shape that looked like a smile and looked like a frown. Yeah? And it was easy to pick up. This here does not look like a smile or it doesn't look like a frown. So when we change A to be a negative, what it does is it just flips it upside down. So from the top, it will drop to the bottom. From the bottom, it will drop to the top. Okay? That's why quadratics, when it was like this smiley shape, it flips to the bottom, it looks like a frown. That's why. Okay? Quiet down.
How do you know?
Quiet down. Thank you. So, what A is responsible for is, and this is what I want you to write down over here, as you're writing your notes, make sure to write A will make it narrow or wider from the asymptotes. See, these are your asymptotes. It's either going to stretch the graph away from it, or it's going to stretch the graph closer to the asymptotes. And I'll show you in the GeoGebra so you can see what A does. I'm going to change the A value so you can see what it does, because now you know what B does and you know what C does. I want to change A so that you see what happens to it. I want to change A to a negative so you can see how it flips as well. Okay? So have a look at this one. So this is what I want you to just write your notes there, and I want you to look at the graph. Write your own notes on the graph, yeah? So watch me change A. I'm going to go to GeoGebra now. And you can have a look. Whoops, not that one. Here we go. This is your graph. This is your 1 on x. True? That's what you're used to seeing. I'm going to change A, which is the value of 1. I'm going to change that A value. So watch me change it, and I want you to see what happens to this graph, whether it gets stretched out or it gets thinner. Yeah, watch me as I change the value of A over here. So watch me here. Wait, so now I'm going to change this. Yep, but I'm going to teach you how to find axis-intercepts as well. Okay? So we go A. When I change A to 2, have a look. When I change A to 2, what's happening to the graph?
One arrow.
What's happening to the graph? As I increase the numbers, what's happening?
Stretching.
Stretching away. Can you see how it's stretching away from the asymptote? So if I take away the blue line so you don't get confused.
The X and Y, that's the same, right?
Yes. Very good.
What you say?
Very good. What Sydney just said just there, I want you guys to pay attention to that. A only stretches it. It doesn't change the asymptotes. When does the asymptotes change? It's only when you move left, up and down. Left, right, up and down. That's the only time you change the asymptote. The green lines are your asymptotes. They don't change. The only thing that changes is the stretchness of the graph. Will they still come close to the y-axis or come close to the x-axis? So watch, as I change A, see look, I increase A, it just stretches away if I increase the number. If I decrease A, it gets closer and closer, but now watch when I get to a fraction.
How do you find the peak of it?
Wait, shh. It goes on infinitely. Watch when I go into the fractions. So 0.8, 0.4, 0.2. Can you see how, oops, no, not negative. 0.2, can you see how it's getting closer and closer?
Make it 0.
To the axes. If you make it 0, remember 1 over 0 is?
0. Undefined.
Undefined. You can't divide by 0. Okay? That's why there's an asymptote here. Okay, you can't divide 0, that's why there's an asymptote. But the closer you get to, the smaller the number is. So 0.00001 will make it very close to the asymptotes. That's all it does. Now watch what happens when I change it to a negative number. So I can have -1. Yeah, it just swaps sides. So if I change it to -1, see that's -1. All you did was the shape was over here, and it flips. Will and Lauren, does that make sense? Yeah, pay attention. So -1 for the A, Sydney, don't talk while I'm speaking. Now, when you have A as a negative value, it will just flip upside down. That's what A does. Yeah? So if A is a -1, it flips down and the bottom flips up. Now watch when I increase that negative value. If it becomes -2, can you see how it just stretches? The number, as it increases, it just stretches. But the negative tells you that this is the shape for a negative. For a positive, it's the other way around. Okay, so it either gets closer to the asymptote or moves away. Yeah.
You know, like, so if you increase the number, right, it does move far away.
Yep.
Yeah, but when it becomes small,
Yep. So watch. If I gave it as a 0.6, it gets closer and closer.
Yeah, but when it gets small, I mean the size of the size of the graph, the size of the graph.
No, it just gets stretched closer or it moves away.
So this will be only.
Yep.
Either red, either diagonal.
Yep. All right. Now, just what you've been doing over listening. You know how you were doing the exercise last session? I told you all I wanted you to do was sketch left, right, up, down. And your main thing that I wanted you to do was the asymptotes. This is what I wanted you to do. When you have a +1, so let's say +2 there, sorry. When it's +2, all you have to do was you told me to find out whether it was left or right. Let this equal to 0, solve for x. Now if you solve for x here, it's a -2. And can you see the asymptote now is at -2. So the shape still goes the same, but approaches -2. Y asymptote still the same. The only time it changes is if you move it up and down. So if I change this C now, if I change that to +3, well, I'll go to +3. You can see all you have to do for these graphs here, get the asymptotes correct. Get these correct. So 2 to the left, up by 3, draw the graph as it is. That's what I'm looking for. Okay? So we're going to do 3 examples. You're going to be sketching graphs. I'm going to do 3 examples where you find the axis-intercepts because you haven't found x-intercept and the y-intercept. I want you to find that now. Okay, so that's what we're going to work on for this lesson. That's exercise 4A. And then when I give you your homework sheet, that puts everything together. Okay, so you should now be able to tell me asymptotes, find axis-intercepts, put them all together and sketch. That's what exercise 4A is about. Okay, and that's due on Monday. That's what I'm looking for. Okay? Now, let's do an example together. Let's have a look at this one. Here we go. Ben, having a look at this example 1. What does the -3 do? Can you tell me what's -3 do? Moves it down by 3. Trent, What does the x plus 1 do?
It moves left 1.
Moves left by 1. Fantastic. How do you know again? Let x plus 1 equal to 0. Solve for x. You can tell that's a left by 1. Okay? Now, what does the 2 do now? Can I please have Will? What does the 2 do?
It makes it narrower or wider.
Yeah, in this case, 2 will make it wider. Stretches it out from the axes. Okay? Now, how do you sketch this graph? 2 is a positive number. So we know the shape has to be like this if it's positive. Now, if you were to sketch, always do the asymptotes first. So where would the asymptotes be now? Hamish, where would the asymptotes be if you know?
Down 3.
Fantastic. That's what you're going to write.
It would be negative 1, 3.
Good. So you got asymptote at x equals negative 1. Okay, that's your vertical asymptote. Your horizontal asymptote, you said down 3. So I'm going to do down 3. Draw your vertical...
What do you call the intersection of those asymptotes?
Nothing. Yeah. No. Okay, so this is called y equals negative 3. These are your two asymptotes. That's what I wanted to see when you were sketching. Now, if you were to sketch the graph, the only thing you need to do now is you can draw it like that. Okay, but the problem here is, see, this is the shape. You've got your shape. I'm just drawing it closer to the axes and closer to these axes. Yeah, that's why you need the asymptote. But the problem is you don't know the x-intercept is here, and you don't know if the y-intercept is there. So your job now is to find x and y-intercepts. Now let's go back to year 9 maths. How do you find the y-intercept again? Felix, what do you do? Good. So I'm going to rub this off here. We're going to find y-intercept by letting x equal to 0. So here we go. Copy this down. Find y-intercept, let x equal to 0. So watch this. You got y is equal to 2. Whoops. 2 over 0 plus 1 minus 3. Let's work this one out.
Should we just like multiply under the bracket?
No, I'm just doing sub x equals 0. Let's solve this one. You got 0 plus 1, which we know is 1. 2 over 1 minus 3. What's 2 over 1? 2. So we've got 2 minus 3, which is equal to?
Negative 1 over 3.
What?
No, I mean, I just omit this.
All right, well, y is equal to negative 1. What does that mean? It just means your y-intercept. That's what you were working out for, yeah? That x equals 0. Sub x equals 0 into the equation. Solve for y. Now you know the y-intercept is negative 1. So put a point on your intercept. So here we go. We've got a y-intercept at negative 1. 0, negative 1. Now if you want to find your x-intercept.
Y0.
Y0. So here we go. X-intercept. Let y equal to 0. So let's do this one. I'm going to let y equal to 0. So y is equal to 0. 2 over x plus 1 minus 3. Now a lot of students don't like fractions. So I'm going to teach you how to do this one. You got 2 over x plus 1 minus 3.
Negative 1 over 3.
No. Let's try to solve this one. So how do I solve this? Let's start off. Lucy. Move the 3 across first. That's the first thing. Now you've got a minus 3. Opposite of minus 3?
Plus 3.
Plus 3.
Plus 3.
Yeah. Good. Now you got 3. Plusing 3 on both sides. Will, pay attention. 2 over x plus 1. Okay, Will, you do this one now. You got 2 over x plus 1. This is where a lot of students find it difficult. So how do we try to find x? This is back to year 9 maths again. It's fractions.
What was that? X plus 1 equals 0.
No. Fantastic. See, when it comes to fractions here, sorry.
But then you
I'll give you the next one. You can do the next one.
Okay. So, but then you just move the fraction over to the other side.
Yes, you can, but
So no, but you've already done that. It's 3 over x plus 1 then, isn't it?
No.
Or you times it.
You times it. Yeah. So here we go. So up to this step, remember fractions. Fractions, if you read it, this is just to divide. And the opposite of division is multiplication. So you're just going to multiply both sides. And I'll teach my year 12s the same things. I say if you want to get something rid of the denominator, it's okay. If it's divide, do times. Times both sides by the denominator and it's fine. So here, what you're meant to do with fractions, don't get afraid with them. Here, you're meant to just say times both sides by x plus 1. And we know that x plus 1 divided by x plus 1 will cancel out. So now, you have 2... Ryan, focus. You got 2 is equal to... Now you got 3 times x plus 1 Okay, now we would have solved this. You can expand the brackets. That becomes 3x plus 3 is equal to 2. Now this is something you like. See, this is what you're used to. Now let's solve this one now.
Make the 3 go over that side.
Okay, so that's a plus 3.
So it'll be -1.
Good. Minus 3 on both sides, so 3x.
Equals -1.
-1. Now to find x.
It's going to be -1 over 3.
Fantastic. Now was that easy? Okay, you got y-intercept, x-intercept. Label it, and then you can sketch. So here we go. I'm going to put my x-intercept in. This is at -1/3, 0. You know the shape of the graph already, so here we go. There we go.
How do you find the peak?
The peak.
Like of that line.
Here. I just know the shape looks like this.
Would it keep going?
And all I know that it just goes on infinitely.
How do you draw
It just keeps going, no, it just keeps going up and closer to this vertical line.
How do you draw the prophet?
Is it
How do
possible?
you,
How do you draw like some like prophet like
you just try to draw close to this and then close to that. And everyone will draw it slightly different. But you need these 2 points. Okay? X-intercept, y-intercept, that's the goal. So your homework sheet, that's what I'm looking for.
Would you
And what do we get?
need it to find like you see how like when a line goes like the parabola goes up, right? Does it peak on this way?
No, it goes on forever.
So, but like it comes down this way, but you have to find that one.
Oh, no, you do. Oh, I see what you mean. You're talking about here.
Yeah.
Now it doesn't have a turning point. So it doesn't come back up. This one just keeps going down and down and down. No, none of that. All you need are asymptotes and axis intercepts. That's it. These two and the axes. Okay, so last session I taught you how to find the axis intercepts. Will, if I have to call you again, you're going to move to the front with me. Is that cool? All right. You can find the asymptotes from what I taught you last session. Left, right, up, and down. That's what these asymptotes are. Yeah? The only thing I'm teaching this session is to find your x-intercept and your y-intercept. Okay, that's what I'm going to do. Let's try another one.
For that one like
Yep.
you know like for when you drawing right, it should be like X closest to the asymptote one.
Yeah.
Yeah, but try to solve one. That's try to one.
Which one?
The one.
This one.
Nah, other one. No, yeah. Nah, other one.
This one.
Nah.
This one.
Yeah, kind of far.
Oh, as long as you show that you're getting close to it, it really doesn't matter at this point. You just got to show you're getting close. Okay? Let's do another one. Here we go. Let's read. Shh. Quiet down. Next person. Let's go, Finn. What's the x minus 1? Tell me. Good. Again, if you can't remember, let it equal to 0. Solve for x.
Pretty much like the opposite of the sign.
Yep. Just be careful. Sometimes they put a 2 here, so that's why you have to solve it. That's why I'm teaching you to solve. Yeah. So we know it's to the right by 1. So draw the asymptotes. Do the vertical asymptote. Right by 1. So I'm going to do a vertical asymptote. X equals to 1. Yes, Sydney?
If that bracket, that x minus 1 bracket was like bracketed and put like in like a number for that, we just like disregard that number.
No, you keep the number as well, because it's all in the denominator.
Yeah, but like it's like 2 bracket x minus 1 bracket. Well, I just disregard the 2 and do like x minus 1.
No, it'll be 2x minus 2. Yeah. Just to be safe. Just to be safe.
So basically, just finding x intercept and y intercept, it's just the denominator.
Yeah. This is to find the asymptote. It's not to find the intercept. Yeah. Then just the denominator. Cool. All right. Next one. Does this graph move up or does it move down, Rachel? No, it doesn't, because I don't have a plus c. So this is a plus 0, so it doesn't go up and it doesn't go down. So therefore the asymptote is still at y equals 0. See how I'm doing it? Once you draw the axes, it's easy now. Now you can just draw the graph. But the problem is you don't know where the axis intercepts are, so you have to find that. That's the only extra thing I'm teaching today.
So
yeah?
for the graph without C, right? So asymptote is always 0.
Yep. Because that's where it starts. Okay, now, let's do this again. Y-intercept. How do I find the y-intercept? Trent, what would I do?
Let X equal to 0.
Let x equal to 0. Next one, Lauren. I want to find y-intercept, so I'm going to let x equal to 0. So what would I end up with? Fantastic. It'll be 0 minus 1, so it's -2 over -1, which is 2. So now I know my y-intercept is at 2. So on 2, put your coordinates. 0, 2. I've got my y-intercept. Now I need my x-intercept. How do I find my x-intercept? Can I please have, let's go with Sydney.
Y.
Good. Let y equal to 0. So I'm going to go to this one. Let y equal to 0. I'm going to do it in red. Fantastic. Good. Now negative 2 over x minus 1. Here we go. Same thing with the fractions. If you don't like fractions, it says divide. Opposite of divide is times. Times both sides by x minus 1. Now what's going to happen here is if you times both sides by x minus 1, this will cancel out. But look at this. 0 times anything is 0. So what does this mean? You haven't done anything wrong. Yeah, there's no y-intercept because you can look at this graph here. I mean, there are no x-intercepts because we said here it's an asymptote. So of course, you don't have any axis intercept on this because the asymptote's right there. So if you sketch it, it only goes through, 0, 2, but it doesn't cross through the x-axis. Yeah, I'll grab that. Sydney. No, because this is untrue. 0 doesn't equal to negative 2. So no solution is what this means. So it means no x-intercepts. So, how is this possible? There's only one piece of information I'm missing right now. How is it possible if you draw your shapes like this? How do I cross the y-axis intercept? What am I missing? There's one little thing that I haven't looked at. The negative. Remember A? I said that A will flip it. And you're missing that negative 2 there. So that's why the shape of the graph should look like this now. It should be the other way.
Oh, I see.
And then it looks like that.
That means it would touch the
No. Because remember you've got an asymptote.
Yeah, but it's above the x-intercept.
It's below.
Oh, it's above.
So I'm drawing closer and closer to
Wait, so is
the
the asymptote above the x-intercept?
Oh, sorry, I did the dotted line. It's meant to be on 0. That's why I labeled y equals 0.
Oh, okay.
So it's meant to be on the x-axis.
But it doesn't.
Yeah. It's meant to be on the x-axis, so it's approaching.
Yes.
Okay?
Wait, what is straight line? Straight line.
Wait. Shh. Quiet down.
Trent shows you that there's no solution.
The negative 2 is the negative part. So you know how the graph was like this?
Yeah.
Then the negative will make this come up.
So it flips it.
It flips it. And that's why the quadratics, when you put a negative on it, it flips it and it goes
I see.
like that. And same thing with cubics. Cubics was that if you put a negative, it switches. It's the same thing with these shapes. And any other shape you're going to do, it's going to be the same thing. Yeah? All right, last example. Here we go. Be careful with this one. I tried to make it a bit trickier, and it's on your homework sheet as well. Last one. Let's read. Hamish,
Okay, go back to the graph.
what's this positive 2 do? Say it again.
Oh, the y.
Not the y-intercept?
Up or down.
Good, up or down. So this tells me up 2. What's the x plus 4 tell me down here? Can I please have Yasmin? What's the x plus 4 tell me?
Sorry.
Left or right? So this is left by how much? Left by 4. Fantastic. So it's negative 4 tells me left 4. So now I've got up 2, left 4. Draw the asymptotes. That's what I want you to do first. That tells you where your boundaries are. So we go up 2, up 2, y equals 2 there. When you draw the vertical asymptote, remember to label it. It's across 4. So we got left by 4, x equals negative 4. Now the question is this a positive graph or is it a negative graph? How do you know? Lucy, negative. I know the 4 doesn't have a negative on it, but look at the front. See the front, wherever you have a negative anywhere close to the fraction, okay, because if I remove the 2 there, that negative is changing that 4 to a negative. Okay, so negative, that tells me the graph is the other way around. So be careful with those negatives. A lot of the times in the exams, that's what they do. They purposely put a negative there so it's not obvious because they move the 2 to the front. Okay, usually it's plus 2 over here. I'll just put plus 2 over here. Doesn't make a difference. Okay, so now I know the shape. The only 2 things I'm missing, x-intercept, y-intercept. So let's do the same things again.
Oh, I see.
That's fine. Y-intercept. How do I find the y-intercept again, Will?
Make x 0.
Good. Let x equal to 0. So you got y equals 2 minus 4 over 0 plus 4. Oh my God. 2 minus 4 over 4. What's 4 over 4? 1. 2 minus 1. 1. So that tells me y-intercept is at 1. So I'm going to write 1,
That makes sense.
0, 1.
Hold on, but that's two.
Oh, sorry. No, you're right. Thank you for correcting me. 0, 1. Okay. What? And I need to find my last one, which is x-intercepts. So here we go. And how do we do that, Will? How do we find the x-intercepts? Yeah. Yeah. Good. Now, before you do that, you're going to be careful. What do you have to do first? Let's have a look. Matt, what am I going to do now? I've got 0 equals 2 minus 4 over x plus 4. Good. See that 2 there? Get rid of those terms first. Leave the fractions to last. Get rid of any other things that are in front. I'm going to plus 2. Opposite of plussing 2? Minus 2. Minus 2 on both sides, I get negative 2 equals to negative 4 over x plus 4. Times both sides by negative, because these two are negatives. Okay, times both sides by negative 1. So if you times both sides by negative 1, you now have 2 is equal to 4 over x plus 4. Now up to this step, you can do what Will was trying to say before. What do you do with the fractions? Fantastic. Thank you. Same techniques. It's divide by x plus 4, so the only technique you got to do is times both sides by the denominator. Times both sides by x plus 4, times by x plus 4. Now you get 2 bracket x plus 4, so you get a 4. 2x plus 8. Let's solve that. What does that equal to? Good. Bring the negative 8 across. 4 minus 8 is negative 4. Negative 4 divided by 2. X equals negative 2. Sub in the coordinates. Negative 2. 0. Now you can draw your graph. You know it was a negative graph. There you go. Was that easy? Okay. Left, right, up, down. Get your asymptotes first. Find y-intercept, find x-intercept. Label and sketch. Just be careful with the shape. Okay, I'm going to leave that there. That's exercise 4A. I expect that to be done.
So the conclusion for the what's the line of
Asymptote.
Yeah, it's always up and down, and left or right x 0. Yeah. And then 1 x 1. They're gonna stop.
Perfect. I'm going to stop the video.